The OS module in Python is a part of the Python standard library that allows you to interact with the operating system. It provides functions to navigate the file system, handle files, handle directories, and manage environment variables and execute system commands. The module is really essential for performing system-level operations and automating tasks within your programs. So let's head over to PyScripter and check it out. Okay, we are in PyScripter. Let's take a look at some basic commands using the OS module from the standard Python library. We'll begin by opening up a Python script. We'll remove the default code and we're going to import OS. Let's start by getting the current working directory of our operating system and our PyScripter IDE. So CWD stands for current working directory, and we'll set this to equal os.get CWD. We will then print the CWD to screen. We'll run that. And we can see it is pointing to a temp folder on my C drive. Yours might be different, and that's okay. If we were to create a file within Python and write it out without specifying a location, this is the location our file will be written out to from PyScripter. And we'll take a look at that when we look at the CSV module. Now I'm going to go over and comment out our code. And I'm going to change the current working directory with os.chdr. Now I need to put in a path to the directory that I want to become the current working directory. I'm going to add in the path to our reference Python scripts. Now, as we know, these backslashes are for escape characters when it comes to strings. We have two options here. We can put in double backslashes. Sorry, we actually have three options here. We could change all the backslashes to forward slashes, or we could keep the single backslashes and place or in front of our string, which stands for raw. So basically override any escape backslash and just treat it as a normal backslash. We'll use or. I'll copy this CWD line of code here. We're going to get the current working directory again. And we will also print the current working directory. We'll click run. So you can see that initially our current working directory was our temp folder, and when we change directory, it is now our reference folder in our Python scripts. If I show you that folder, we can see that there are 16 folders within the reference directory. I'm going to create a variable called files. I'm going to set that to os.listdir, which stands for like list directory. And I'm going to supply in the current working directory, which is our reference folder. And I'm going to print files to screen. I'll clear the interpreter and I'm going to run. And we can see we have returned a list containing each folder name in our reference directory from our current working directory. We can see that our standard Python library is our last one there. We can access that using -1 for the list. And let's use SPL path, that's standard Python library path, as a variable. And we'll set this to equal os path dot join. We want to join our CWD and our files -1, and we will print the SPL path. I'll clear over here and we'll rerun. Oops, that should have been files instead of file. I'll clear again and rerun. So we have three prints in our script. We have the current working directory, we have the list of directories that we've called files, and we have a new path to our standard Python library folder. Go back over to the script and I will print os.listdir, and I'm going to supply in our SPL path. I'll clear the interpreter and run again. And we can see that our list dir for our SPL path has returned the 4 Python scripts that are in our standard Python library folder in our Python scripts. And if I bring back up our folders and we click into our standard Python library, we can see the 4 Python scripts that match what was returned from our script. Now we'll look at creating a directory. We'll use os.makedir, and we're going to use our path.join once more. Say os.path.join, and we want to supply in our SPL path. We're going to make a folder within our standard Python library folder in our Python scripts, and we're just going to call it test folder. Now when we print using list directory on our standard Python library folder, I'll clear the interpreter window and run. I apologize, there is no function called makedir, it is actually mkdir. I'll clear the window and we'll go again. And we can see our last printout here. We have our 4 Python scripts and we have our test folder. If I open up the folder, we can see that test folder has been created. I'll comment out the making of our test folder, and we're going to delete that folder. I'm going to say os.rmdir for remove directory. And I'm just going to copy the SPL path and the test folder here for the join. This is what we want to remove. So our SPL path goes to our standard Python library folder, and we're using join to create the path to the test folder within there. We could just write out the whole path as a string, but this whole video is about using the OS module. We'll rerun and we will check our folder, and we can see that our test folder has been removed. Now always remember, be very, very careful when you are doing any deletions or removals using Python. You could lose a lot of data. Fortunately, with Windows, that'll go into the recycle bin and we could retrieve it. But if you are deleting from a file geodatabase, it can be gone forever. In this video, we got an introduction to the OS module, the operating system module with Python programming. It is a part of the standard Python library. We saw how we could change the directory that we are working in and how we could return files and directories that are in that folder. We also saw that we could create folders and also delete folders, and you can do the same with files, and we'll see that when we check out the CSV module in this section. There's plenty more you can do with the OS module, such as managing environment variables and executing system commands. So I advise you to go and explore the OS module to get a better understanding of its capabilities.